do that normally. Here it is. All right, we're moving on. Let's see if Canvas is posted. No, no Canvas. All right, let's evaluate the derivative at 1/2 pi over 6. Okay. So dy dx 1/2 pi over 6. That means we put cosine pi over 6 in for the thetas and 1/2 in for the r's, but there aren't any r's. So all we have to do is put in pi over 6 for the thetas. What is cosine of pi over 6? Root 3 over 2. So we have negative root 3 over 2. Sine of pi over 6. Your unit circle. 1/2. Plus, parentheses, 1 minus sine of pi over 6, that's 1/2 again. Cosine pi over 6, root 3 over 2 again. All right, there's the numerator. Now the denominator. Cosine pi over 6 is negative root 3 over 2. Then we have another one, root 3 over 2. Minus, same thing, 1 minus 1/2. Sine of pi over 6 is 1/2 on the end. This we are going to simplify. You guys all right with all that plug-in stuff there? Substitute everything in. We put pi over 6 for the thetas and evaluate it. So simplifying this, negative root 3 over 2 times 1/2 is negative root 3 over 4. Over here, 1 minus 1/2 is 1/2, and 1/2 times root 3 over 2 is root 3 over 4. What can you already say? What's the answer going to be? 0. It's going to be 0. The numerator is coming out to 0. It must be 0. The only thing that could mess that up is if the denominator is also 0, we get a 0 over 0 situation, right? That's the only thing that could mess it up. Well, let's check that. Negative root 3 over 2 times root 3 over 2 is 3/4. Negative. Because root 3 times root 3 is 3, and 2 times 2 is 4. 1 minus 1/2 is 1/2, and 1/2 times 1/2 is 1/4. Is that denominator going to come out to 0? No. But the numerator does, so the answer is 0. Let's look at the graph. Okay, there it is. And at pi over 6, well, I thought it would give us the line. It doesn't. Let's zoom in. So pi over 6 is like 30 degrees. So that should take us right there to that peak. Do you agree that the tangent line is going to be horizontal right there? 0 slope? Does everybody agree with that? So let's do this. What was I going to do? let's find, let's go to our original function. Erase this. Our original function there is r equals 1 minus sine theta. And let's figure out what we get for theta equals pi over 6. So that would be 1 minus 1/2, which is 1/2. So the point is 1/2 pi over 6. All right, let's label that point on the graph.
Well, you already had that point over here.
Well, it did not do what I thought it would do. Did we do that right? Oh, it's because, see, it's putting it in rectangular. It's Desmos, it's not our work. Our work is correct.
Yeah.
Desmos is not doing what I want it to do. All right, then, let's convert it to rectangular. So this is polar. Using these here, x is r cosine theta. So x is 1/2 cosine pi over 6, which is 1/2 times root 3 over 2, that's a 3, which is root 3 over 4. And y is 1/2 sine pi over 6, using this, which is 1/2 times 1/2, which is 1/4. So in rectangular, we have root 3 over 4, 1/4. So let's change that to, oh,
Oh, turn it off.
root 3 over 4, 1 over 4. There. You guys see it there?
No, turn it on.
You can't see it, oh. Now do you see it? Now, do you see that the slope of a line tangent there is going to be 0? It's a horizontal line that's tangent right there, right? So the slope is 0. In
Right.
fact, the tangent equation would be y equals 1/4, that y coordinate there. There's the tangent line. You guys believe it worked? Let's review what we did. What's he talking about? All right, we use this to find the derivative. Here's our function. Here's changing r to f of theta. There it is with function notation. Now using that, f prime of theta, the derivative of this is negative cosine times sine theta. Okay, work through this whole thing. We got our derivative. This is the derivative right here. Now we evaluated the derivative at this point. When you evaluate a derivative at a point, it gives you the slope of the tangent line at that point, correct? In Math 5A it did that in first semester calculus. We're doing that right here in polar. So we put in this point, which means we only put in the pi over 6 to these thetas and evaluate that, and our slope came out to 0. And so now we saw on the graph, well, okay, our slope is 0, but where Desmos won't graph these coordinates in polar form, So over here, I converted them to rectangular. I don't know why, when we're on polar form, it's graphing rectangular when you put in individual points. So that point, 1/2 pi over 6, is there. And I just did this to show you that the slope of the tangent line there is indeed 0. Please believe it. Are we good with that? All right, let's do one more derivative, and then we will be finished. Just to make sure we got it.